Hello, guys. Welcome back to Maison African Motives for the membership platform. Thank you guys for being part of the membership family, which is very, very important. So in this platform, I've got a question that you're going to focus on the differentiation, which is actually taken from the question paper of April 2015. So we've got question number 4 that we are having. So let us quickly rush through the questions and see what we're supposed to do. So the first part, we are being given y is equal to 3, x to the exponent of 3 plus 19x to the exponent of 2 plus 27. If this was supposed to be the second derivative, there's supposed to be a 2 there. So, the second derivative of y with respect to x is equal to 0. Solve for x. Okay, so we are given to solve for x if the second derivative is equal to 0. So knowing that the second derivative is actually obtained from the first derivative. So what you need is to find the first derivative first. So the first derivative of y with respect to x. Okay, so remember the derivative, you drop the exponent, which means you're going to multiply here 3 times 3, which is 9x to the exponent of, we subtract 1 here, so 3 minus 1, that is 2. Okay, on 19 x squared, we do the same, we multiply 2 times 19, which is actually 38. So this is going to give us 38. We subtract 1, so 2 minus 1, that is 1, so it is going to be x. Okay, 27 is a constant, knowing that the derivative of a constant, that's a 0. So that's our dy dx. Then we'd find the second derivative. So that's the second derivative of y with respect to x is equal to, all right, so let's differentiate. 9 times 2, that's 38. 9 times 2, that's 18. Sorry, guys, that's 18x. Okay, then we've got 38x. So take note, this is a linear expression. So we just have to take this 38. So it's plus 38. So this is the second derivative. Then here we are given that the second derivative is equal to 0. So that means we are going to equate this second derivative to 0. So that means 18x plus 38 is equal to 0. Okay, so we can solve for x. It's a linear equation that we are used to. So all we need to do is to transpose 38 to the other side of the equation. That means 18x is equivalent to minus 38. We can divide by 18 both sides. So we can obtain the value of x here. Okay, so our x is going to be equal to what? Let me just share the screen with the calculator so that we can see our calculator here. All right, so let's divide this. Okay, so let's do this, guys. Minus 38 divided by 18, which is negative 19 over 9, or negative 2,111 and so forth. So it's negative 2,11. Okay, so that's the value of x that we are obtaining in this case. So these are the typical questions that you can actually have. Okay, let's see the other part of the question. Question number 4.2. Determine, we are given the following limit. We are given the limit of x to the exponent of minus 3 minus 125 over x minus 5, where limit x approaches to 3. Okay, so if x is approaching to 3 of this, how can we simplify? Okay, let's just have this aside. That can be best. Okay, so I'm just going to rewrite this question aside here. All right, so we are given that this is 4.2. We want to find the limit as x approaches to 3 of the expression that is x cubed minus 125 over x minus 5. Okay, so for you to simplify this, actually here they are targeting you to factorize x cubed minus 125. Remember that 125 can be written in terms of 5, which is 5 to the exponent of 3. Okay, if you multiply 5 times 5 times 5, that's 125. So how can we factorize this? We know that from our factorization, if we are given x minus a to the exponent, okay, sorry for that, guys. Okay, if you are given x to the exponent of 3 minus a to the exponent of 3, the answer is going to be x minus a into x squared plus ax, take note here, plus ax plus b squared. Take note of this. Okay, if it is a positive, x cubed plus a cubed, it is going to be x plus a into x squared minus ax plus b squared. Okay, so take note of these identities. So this is what we are going to have here. All right, this is our x, okay, the x that we have, and this is our a, okay? So this is your x, this is your a. So using this part, we can note that we are going to have something like limit as x approaches to 3 of x minus a. Take note here, it's x cubed minus a cubed. You're going to have x minus a, which is x minus 5. Our a is 5, okay? So it is going to be x minus 5 into x squared plus ax. So it is going to be this x, which is x squared plus ax. Your a is 5. So it's 5 times x. Okay, so it's going to be plus 5x plus b squared. Okay, why am I having the b? This is a squared. Okay, so I hope someone is being surprised. Where is this b coming from? This is a. Take note, guys. I was like taking with a. So this is a squared. Okay, so we're going to have 5 to the power of 2. That is 5 squared. So 5 squared, that is 25. Okay, 5 times 5, guys, that's 25. Okay, so this is what you're going to have after factorizing. So we are going to have this over. All right, so that's everything over x minus 5. So there is a miracle that is going to happen. As you can see, x minus 5 are the same. So these two can cancel out. So which means we are going to remain with the limit as x approaches to 3 of this whole expression, that is x squared plus 5x plus 25. So what does this part mean? It simply means that we are going to substitute in place of x, you are going to substitute 3. So in place of x, substitute 3. So you're going to have 3 squared plus 5 times 3 plus 25. Okay, so this is what you're going to have at the end. So it simply means from your calculator, you can simplify this from your calculator. Let's see what you're gonna have. So let me again share that screen that has got the calculator so that we can see our calculator here. All right, so that's it. We can see our calculator now. So that's 3 to the exponent of 2. 3 to the exponent of 2 plus 5 times 3. Okay, plus 25. Okay, so that's what you're going to have, which is 49. So we are going to obtain 49 in this case. Okay, so that was the derivative, that was the limit that we are given. So limits are actually part of the derivatives. Okay, on 4.3, we're given to differentiate the following in terms of x. So we are given there, differentiate these expressions in terms of x. So what you're supposed to do is to rewrite in a way that you can actually integrate direct if it is needed. But if it is direct, then you can just integrate. Like for this one is direct, guys. Okay, remember that the derivative, okay, so you can just write it here. dy dx is equal to ln is 1 over x. So it is going to be 1 over x like this, divided by 4 like this. So 1 over x divided by 4 is the same as writing as 1 over x divided by 4, which is the same thing as 4 over 1. So it is going to be 1 over x times 1 over 4, which is going to give us 1 over 4x. Okay, so this is going to be 1 over 4x. Okay, so that was the derivative of this part. Then we move on to minus 3 cot. Remember that cot gives us negative cosec squared. So this is going to be negative cosec squared x. So negative times negative, that's a positive. So it is going to be positive 3 cosec squared x. Okay, then we've got 7 to the exponent of 3x. Okay, let me just rewrite this down. The derivative of y with respect to x, if we are given, let's just say this is k a to the exponent of f of x like this. Okay, we are going to have our answer as k by the first derivative of f of x, then a times a to the exponent of f of x. Okay, so this will be, okay, I think just need to reduce down, okay, like this. So this is a to the exponent of f of x times ln a. So you have to memorize that, because somehow on your formula sheet, they don't give exact, they just give a basic way of having this. They do not give like everything that you're supposed to have. Okay, so that's it, guys. In this case, we do not have the constant k, so we do not have this k, so we just have to find the derivative. Okay, so what is the derivative here? That's plus, okay, like this. So you're going to have plus the first derivative of x. So this is our x here, 3x. So the derivative of 3x, that's 3. Okay, a to the exponent of f of x, that's 7 to the exponent of 3x. So it's going to be 7 to the exponent of 3x. Ln a is the one that is the best. So the best here is 7. It's 7 to the exponent of 3x. So it is going to be times ln 7. Okay, so that's the derivative of everything for 3 marks for that. Okay, I think this one was much easier. Okay, it's not much easier, but it was a direct type of a question. Okay, anyways, let's check what we have on 4.4. Just going to remove this part here. So on 4.4, given y is equivalent to 2x minus 1 squared, from this part, differentiate by the use of function of a function or chain rule. Okay, so you're gonna just write this aside. Okay, so that's 4.4. Let's see what we have here. Okay, so 4.4. So we are given that y is equivalent to 2x minus 1 to the exponent of 2. So this is 2x squared actually to the exponent of 2. Remember what I told you guys, if you are dealing with function of function, you must know the formula which says that the derivative of y with respect to x is equivalent to dy du times du dx, whereby you have to introduce u on the part that you can actually find the derivative. Like we can differentiate 2x minus 1, 2x squared minus 1. So this is the part where we are going to introduce u. So let u be equivalent to 2x squared minus 1. That means we can now rewrite this, because in place of 2x squared minus 1, it's now u. So this will be u squared. So y is equivalent to u squared. But if we are to check on our formula, there is dy, du, du dx. So that means we have to find the derivative of y with respect to u. Where can we obtain the derivative of y with respect to u? That's where there is y and u here. So we can find the derivative of y with respect to u. So dy du is equivalent to what? Drop the exponent 2, so it's going to be 2u. Okay, if we subtract 1. Then du dx, that's where there is u and x on this expression. So that is the derivative of u with respect to x is equivalent to 2 times 2, that is 4. Then we subtract 1, it's going to be x to the exponent of 1, which is just x. The derivative of minus 1 is a constant, that's a 0. So that's what you're going to have. So now let's substitute into the formula and see what we are going to have at the end. So therefore, dy dx is equal to dy du, which is our dy du in this case gave us 2u. So it's 2u times du dx, that is du dx gave us 4x. So this is going to be 4x. Okay, so that's it. We can simplify further, combine the terms. So this is going to be dy dx is equivalent to 2 times 4, which is 8xu. So you can just write it as 8xu. Then we can substitute the value of u, because this is the derivative of y with respect to x. So in place of u, we can substitute back the expression that is representing u. Remember, we said here that let u be equal to 2x minus 1. So this is your u. So in place of u substitute 2x minus 1. So this means we are going to have our answer as, okay, let's just 2x squared minus 1. Okay, let me just write it here. So therefore, dy dx is equivalent to 8x. So this is going to be 8x into u, which is 2x squared minus 1. So you're going to have 2x squared minus 1 like that. Okay, no need for you to expand the brackets, but if you want, yes, you can expand the brackets, but that is chain rule. This is what you're going to have at the end. So that was question 4.4. Okay, on 4.5, we are given that y is equivalent to x cubed minus 12x squared plus 36 plus 1. Calculate with the use of differentiation. Okay, so we are supposed to use differentiation, the maximum and minimum turning points. Okay, we are not told to differentiate just maximum and minimum, so you just calculate in turning points. Also calculate the point of inflection after that, and that's 7 marks. Okay, so let's just remove this part and see what we're gonna have on this one, on this one. Okay, so let's see, guys. This is what you're gonna have. Okay, what am I doing now? Okay, so that's 4.5. I'm just going to rewrite this question here. 4.5. So we are given an expression for y, which is equivalent to x cubed minus 12x squared plus 36x plus 1. Then you're asked to find minimum and maximum turning points. So we know that for the maximum and minimum turning points, the derivative of y with respect to x must be equal to 0. So all you need is to find the derivative of y with respect to x. Then you equate that to 0. So dy dx, what are we going to have here? We drop the exponent, that's 3 times 1, which is 3x. We subtract 1 on the exponent, that will be 2, minus 12 times 2, that is 24x. If we subtract 1, plus 36, then a constant there, that's a 0. So this is the derivative of y with respect to x, but it must be equal to 0 for the turning point. So that means 3x squared minus 24x plus 36 must be equal to 0. So you can actually reduce this because we can see that 3 is common throughout. So we can reduce by 3 each and every term. So 3 into 3, that is going to be x squared minus 3 into 24, which is going to give us negative 8x. And 3 into 36, that is 12, is equal to 0. Okay, so from this part, for us to solve for x, it's either you can use the quadratic formula or you can just you apply factorization. Since the coefficient of x squared is 1, we can actually do the direct factorization of having 2 brackets that we equate to 0, having x and x here. So remember that you focus with the constant term, which is 12. What are the factors of 12? But if you add these factors, they must give you a negative 8 factors of 12. So we've got negative 6 and negative 2. If we multiply this, we obtain positive 12. If we add, we obtain negative 8. So these are the 2 factors that we are going to use, minus 6 and minus 2. So either one of these brackets must be equal to 0. So therefore, we can calculate the value of x if each of these is equal to 0. So x will be equal to 6 or x will be equal to 2. So remember, these are turning points that you are calculating, the maximum or minimum turning points. Okay, so therefore our TPs, which is at the turning points, we are going to have the first turning point when x is equal to 6, we find the value of y. And the second turning point, when x is equivalent to 2, we find the value of y. So how are we going to do this? We simply have to substitute into the original equation here. When x is equal to 6, we substitute into the original equation. So let me just share back the screen so that we can have our calculator here. So this is what we have. Remember, the first part is when x is equal to 6. Okay, so when x is equal to 6 here, we are going to have 6 to the exponent of 3. So this is to the exponent of 3 minus 12x, which is 6 to the exponent of 2 plus 36 into 6. Okay, plus 1 like that. Okay, so we're going to obtain positive 1, direct positive 1. So take note, guys, make sure that you actually use your calculator properly here. Okay, so we are obtaining direct positive 1. So when x is equal to 6, y is equal to 1. Okay, so we can actually do the same thing when x is equal to 2. So here it's just a matter of changing on your calculator. Where x was 6, you just put 2. Okay, where x was 6, you just put 2. Okay, where x was 6, you just put 2 like that. So we are going to obtain 33. So y is equal to 33 if x is equal to 2. So that's our second turning point. So take note, the question is not asking you to distinguish whether this is maximum or minimum. It's just calculate maximum and minimum. So these are the turning points that you're going to have at the end. So be very, 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 very careful when attempting these typical questions, you need to be very, very careful. Okay, anyways, let's see what we have on the other part. Also calculate the point of inflection. Okay, so we need also the point of inflection here. Okay, so where do we have the point of inflection? For us to have the point of inflection, we must understand that the second derivative must be equal to 0. Okay, so now this time it's about the second derivative. So already we are given the first derivative here. So all you need is just find the second derivative. So the second derivative, okay, so that's for the point of inflection. The second derivative with respect to x must be equal to 0. So let's find the second derivative. In this case, that's the derivative of y with respect to x is going to give us, it's a continuation from dy dx here. So you just have to multiply 2 by 3, which is 6x. If you subtract 1, here is going to be x. Then here it's minus 24. So we've got minus 24. That's a constant. So that's it. So equate to 0 this part, because we said the second derivative must be equal to 0. So 6x minus 24 must be equal to 0. So 6x is equivalent to 24. Divide by 6 both sides, so x is equivalent to 4. So take note, this is a point of inflection, which means we need the value of x, which is 4, then the corresponding value of y. So when x is equal to 4, what is the value of y? So all you need is to substitute on that same equation or expression that we had here. So we are just substituting here in place of x, we're just putting 4 now. Okay, when x is equivalent to 4. So that's it. In place of x, just substitute 4 this time. So we are going to obtain 17. So when x is equal to 4, y is equal to 17. Okay, so that's your point of inflection. So that was it, guys, the derivative part from this question paper. Like I said, it's very, very important for you to work out these typical questions. They have a lot of things that you can actually learn, a lot that you can actually learn. So it is very important that you revise as much questions as you can before exams approaches. Revise as many questions as you can. Okay, so that's what you had, guys, for Method African Motives on Mathematics N4 membership class. Let's continue to invite others so that they join the membership class, so that we can have as much videos as we can. And also you can send your videos, maybe your questions that you have, make sure that you mention them on the comment section so that we can come back and work those questions which are still having a challenge to us. So that's it, guys, till we meet again.